Hello everyone, I am Mohammed Sarfaraz, Assistant Professor in Mechanical Engineering Department from a new college. However, I'm going to present this lecture of subject power generation, and subject code is 883A. So today we are going to discuss about uh, wind energy and wind power in this lecture. So let's see what is wind energy or wind power. So here you can see that wind energy simply is also called a wind turbine, right? So you can see in a figure, this is wind energy which is used for producing electricity, and there are various applications of this wind energy are there. So first of all, what is wind power, wind energy? So wind energy here the kinetic energy of wind is converted. This is basically a conversion of energy from one form to another form. That is, first kinetic energy of wind is converted to mechanical energy with the help of rotors and gear, and then mechanical energy is converted to electric energy with the help of generator or armature here. So wind energy is the indirect source of solar energy, as you know that, because the wind flow due to the difference of temperature, right? So it's also called windmill, which is turned drive a generator to produce electricity. This is basically used for producing electricity, and that electricity is used for various purposes. We'll see further. So wind can be used to provide a mechanical power, such as water pumping. It is also used in water pumping, and the next, the wind power is, we know that it's not new development of power for the traditional purpose. Traditional way we are using wind for various purposes, like traditional windmill for grinding corn, grinding flour, and pumping water, selling ships. These are we are using, but nowadays we are using wind energy to produce electricity through wind mill. So wind energy technology, as we know that, as we see the classification of wind energy turbine. So there are basically two types of classification are there. First is vertical axis wind turbine, and second is horizontal axis wind turbine. We'll see further. There's nothing but there's a difference is location of axis of turbine on the basis of your classification, and there's various types of purposes are there where we are using vertical axis and horizontal axis. And as we know that wind energy generator are there which convert kinetic energy available in the wind to mechanical energy. Then mechanical energy is converted to electrical energy, as I have told you that through the with the help of gearbox and generator. So here is a graphical representation of windmill, wind power wind turbine. You can see that there's a various types of wind turbine are there. First is horizontal axis and vertical axis is there, and through the graphics you can understand the difference between horizontal axis and vertical axis wind turbine. In a horizontal axis you can see the gearbox and generator in a horizontal line. That's why this is called horizontal axis, and these rotor blades are there, and diameter of blade is very important for the calculation of wind power. Further we'll see in a numerical where the diameter and speed of wind plays a very important role. So in the vertical axis wind turbine, you can see the generator gearbox in a vertical form, and these two different types of turbine is used for different purposes. I will discuss further. And here the rightmost corner you can see that horizontal axis wind turbine. So here the graphical representation that how is wind energy, through wind energy electricity is generated, and how is transmission taking place. First is rotating generator convert wind energy to electricity, as we know that, and second is transformer increases voltage for the transmission to substation. Here the transformer is used to increase the voltage, and the third is substation increase the voltage to transmission over the long distances. We know that this electricity we need to transfer in the long distance. That's why we are using third substation, and the fourth is transmission of the grid. And as we know that at the last, this energy, this power is transmitted to the grid, where the in a grid through the grid, this electricity is transmitted to various purposes. Next and most important thing is wind potential. So we can't put this wind energy anywhere. There is some limit or suitability where we use this wind turbine. So in order to in order to trans uh, In order to make this wind turbine, we should have minimum speed of wind, that is 50 km per hour. So here the table you can see the average wind speed and the suitability. If the speed up to 15 kilometer per hour, then it's not good. That up to 15 it is not good. It should be more than 15. So if it is 18, that's a poor. We can say poor. And if the speed is 22 km per hour, that's a moderate. And if the speed increases 25, that's good. We can uh, plant their wind turbine. And if the speed is 29, it's excellent. That's so we can say that what's the most effective condition and speed of wind turbine would be 29. Okay, application, as we know that I have already told you, in the wind energy, this wind power is used for for producing electricity, and this electricity used for various purposes in our household purpose. And as we know that this wind turbine is generated DC current. So this DC current is used for charging of our batteries. In the remote area, we know that where the electricity is not producing, they are using batteries. So there we can use this wind turbine to charging that battery. And also wind turbine for remote pumping generate three-phase AC current suitable for driving an electrical submarine pump directly. Okay, and wind turbines suitable for residential or village scale wind range up to 500 watt to 50 kilowatt. So this is suitability of wind turbine. So thanks for this wind energy lecture. I hope you understand this wind energy, and further we'll discuss about the numerical of this wind energy, wind power, and further slide will discuss about the next bio energy, that biomass is a form of, it's also form of non-conventional source of energy. So thanks for this lecture. Thank you.